Alright, so we're going to review section 1 and section 2. And so in section 1 is all on functions. And the big question to determine if it's a function are the x numbers different. So how they're given to you could be in points. Could be in a chart. Could be on a graph. But a graph could also be a continuous graph. Okay, so in all of these, are the x numbers different? So I don't even care that the y numbers, what they are. Like you notice there's a 3 in the first point and a 3 in the last point where they're the same. Who cares? It's just the x numbers. Okay, so remember that also the x numbers would be considered input and the y numbers would be considered output. But we still look at the x numbers. All of them are different. It doesn't matter that one's positive and one's negative, like the 1 and negative 1. So yes, that's a function. And then on the graphing ones, we do the vertical line test. So if I draw a vertical line, each time I draw it, I should only touch one point. And as long as I only touch one point, that means the x numbers are different. Okay, and so it's kind of the same thing here, just everything's connected. Every time I draw a vertical line, as long as I only touch the graph one time, that means I've touched one point. So all of these are different versions of yes. Okay? So is it a function? Are the x numbers different? So when there's a couple questions that'll ask you to find the domain and range. So remember that the domain are the x numbers and the range are the y numbers. So if you had a graph, if this is just a list of points, then you just list the numbers. So this is kind of like a two-step process for this one because you really should identify all the points. So I'm going to go left to right. So this one down here on the left is -2, -2. And then that one up above is 1, +2. And then this one next to the right is 2, -2. And then that one is 4, 1. So the domain is all the x numbers. And really the order doesn't matter, but usually the book writes them from smallest to biggest. So that's another reason why I went left to right. So it's already kind of the x's are already like that. So the range, I have -2 from right here. I have another -2 right there. I only need to list it once. So then I go to the next biggest is a 1. It's kind of sloppy. And then +2. So if it's just points, you're going to list out the domain and range as just numbers like that. If it's a continuous graph, meaning everything's connected, so if I use the same points but the graph was all connected like that, that means it's including like everything. So what you want to do is you kind of want to make a box. So on the left and the right side, the graph doesn't go any farther to the right and it doesn't go any farther to the left. So this number over here is 2, or excuse me, -2. So remember, domain is x, that's side to side, so that's why I started that way. We write it as like a between or an and statement. So it's everything including -2 here and including +4 over there, everything in between. Then I would do the same thing for the y numbers. And it goes up, starts at 2 and it goes down to -2. So for the range, I would go -2 and +2. Okay. Excuse me. All right. And you'll have a question or two that talks about an independent and dependent variable. And usually those are given to you in like a scenario like format. So let's say that you were part of a team and they were going to do a fundraiser. So and like it said that excuse me, so your team is selling candy bars. For $1. So in just this basic scenario, the independent variable would be the candy bars. And dependent, even though it's not listed in here, if you think about the situation, is how much money you make. So how much money you make is dependent on how many candy bars you sell. Okay? So you'll be asked to identify an independent and dependent variable in a situation. Okay? Alright, and then 3.2 is the function linear. So I think it's pretty straightforward if you, is it a line or is it not? So the one that sometimes trips people up is like this one. Well, it's 2 lines, so it's not 1 line, so it's not linear. Okay, so be careful of that one. So anything that bends, curves, goes in another direction, not linear. Excuse me. Okay. In a chart, okay, you want to look for a pattern for the x numbers and a pattern for the y numbers. And so as long as it must be adding or subtracting the pattern, and it must be the same. So it's plus 2, plus 2, plus 2, plus 1, plus 1, plus 1. As long as they're the same, I should put for x and y. Let me rewrite that. It needs to be the same for x and I'm going to put it separately. Must be the same for y. They don't have to be identical. Like, so plus 1 for the x and plus 2 for the y, they're the same for all the x's, they're the same for all the y's. So this is a yes linear. So if there's a pattern that was like, well, the first one went up 2, and then it went up 4, then it went up 6, well, that's a pattern, but it's not the same number each time. Okay? Alright, and then last I'll have some equations to look at. So I've said it before, I think it's easier to kind of look at what doesn't make it linear, and then if it's the opposite, then it is. So no x squared or y squared no x under a radical sign okay, no x equal a number equations, so no like x equals 2. Y equal is fine, but x equal is not. No x and y being multiplied together. No x or y in the denominator. So if it was like this, That's a no. In the numerator is okay, not in the denominator. Okay, so basically if it's anything else, like, I mean, anything in the form of y equal mx plus b is good. Pick a number for m, pick a number for b, and all the rest of them are good. Anything that's like standard form, we talked about that. A, B, and C are just the numbers. Okay. So these are yes. Any of those things are no. Alright, I lied. There's one last. Discrete domain and continuous domain. Discrete domain is if it was just points. Continuous domain is if it was some like graph where it's continuous, it's all connected. Okay, that's like for a graph. For a situation, you want to ask yourself, can I do half? So shoes, can you have half a shoe? No. So that would be discrete. I mean, you can, you just can't wear it right. So we're not going to get technical and say, well, technically you could have half a shoe. It's true, but it still makes it discrete. Time, can you do half a minute? Can you do half an hour? Yes. Continuous. Okay, can I do half? Alright, so there's a bunch of information. I don't think any of it's too hard to understand. It's just the amount of information you gotta like take in. Okay? Alright, so go ahead and look on Canvas to see exactly what problems you're going to do on the worksheet, and then go take care of that. Remember, we have tests on Friday this week. Alright, have a great day, guys.